Hello and welcome to another tutorial. In this case, we will be learning how to create a great cluster simulation inside Houdini with some great tools. So stay tuned and watch the full tutorial. Guys, do you want to join a really nice server? We have tons of different channels. We have effects, modeling, loop, the compositing. We will have resources for every type of discipline. I also have a Patreon page where you can support me. I have every single file, I have polls, I have even some tools, guidance. So if you are interested, you may have a look. Thank you. Okay, so let's begin. This is going to be coming in and outside from subs and lobs. So look at this. To begin with, what I decided is to create a camera and a grid. Here, what I'm doing is to subdivide so I can then use the triplanar displace copy. This is a modified version of mine where I can choose where the remap goes. It only has a remap. If we go inside and we go inside the point bob, we will see that these red nodes are the ones that are in charge of doing the refit, as you can see. So it's only after the texture you put a fit here on all of these nodes, and you will automatically remap your noise to whatever you want. So in this case, I chose from 0 to 1 to negative 0.525. After this, we're going to create a proxy using exactly the same settings. As you can see, this is just an easy way for me to send something to lobs. Also, I want to optimize the scene for the simulation a little bit. So I use the Frustum, Pizola Frustum, which is a tool that I use and which I created. And basically, this is meant to just create like a curve from the camera, as you can see. It basically just works out of the box. The only thing you got to keep in mind, because it's still not ready, is that the visualize has to be turned off in order for this to work nicely. So this is the frustum of the ground, and this is the frustum of the camera, as you can see. This is also useful. And then I created a bounding box roughly where I want the simulations to happen. As you can see, they are placed similarly to the ground dimensions. To continue, I use this box and this frustum camera to create somewhat of a shape that I can then scatter some points and consequentially use the Wedging Tool, which is a great tool, guys. You should get this in the Patreon to create wedges per camera. So how does this work in this case? Well, the concept is the following. Basically, if you have a grid and you have a camera, what is going on is that I am subdividing the camera based on distance, and we can create boxes where simulations start happening, like the box 0, the box 1, the second, and the third, and so on and so forth. This is particularly nice when I generate static work items, so I can choose the first bounding box, the second bounding box, the third bounding box, and so on and so forth. This outputs a box where I can then use to create a boolean. For example, this is the box that I want, this is the inside, and if I create an intersection, this is exactly what I want. For example, if we go to the first one, this would be the intersection. I think this step is a little bit unnecessary, but then we can clip it. So from camera, basically I'm setting where this smoke is going to begin. Some other things before continuing is how to make something like this from scratch, right? Not the camera, but I can show you another way, which is, for example, if we were to use the same tool as default, we can create basically some bounding boxes where we can extract sections based on a grid. And this is super easy to make. So let's say we want to subdivide these points. What we would be having to do is to create a grid, and this grid we could, for example, have a 3 by 3, as you can see, 1, 2, 3, 4. We could match the size of these points with the grid, as you can see, scale to fit, but not uniform. So now the grid is at the bottom of all the points, as you can see here. Then, if we facet this, we could, for example, make unique points. This means that if I use a class, or a connectivity node based on primitives, and we visualize that, we're going to be seeing that all the squares are 1. And this also means that if we poly extrude these guys, for example, to the top, and we output back, we have boxes that we can, for each named primitive, use. In this case, it's going to be class. So we can go one by one. And in this case, we could, for example, use each one of these guys to blast the points of the bounding box. For example, we could, blast these points which are grouped. Oh, sorry. We could, for example, use this one and keep all of this. We will have an attribute over here which is very nice, very handy. That if we grab a create metadata import, we will have it stored here. This is the number of iterations and this is the iteration. With this taken into consideration, we can continue. For example, let's say we create a blast and we want to simulate on the first square. Well, it's basically class equals to 0, and we can delete this one. And with this, we can select the group of the scatter, which is this one, and we select the points based on the bounding box of the object, which is this one, right? With this, we could blast everything out, which is not the group 1. So we only have this selected. Incredible. And we can do whatever we want. We could use anything. Now, the trick here is to make it automatic. Like, I don't want to be changing this value on my own. I want to make it automatic. So, what you could do with a file cache from Labs is to create a wedging solution. And the maximum amount of wedges is going to be equal to this number of iterations. So what we could be doing is to say, hey, grab the detail of this node. I want the num iteration. I think it was that. Yeah, num iterations. It has to be between semicolon with an S and the first one. This will create automatically 4. So then what we could do is a wedge, and these values, we don't need to do anything. We could reference it over here doing our wedge, and when we click each of these points, it's going to be automatic. And that's basically the main concept behind a clustering tool. In this case, this tool that I made makes it everything from scratch, and we can output, for example, a source file cache, which is with the same idea already connected where we need. Plus, we can send this to deadline because this tool is modified to be working with farms. So that's really good. So this is the bounding box that we create, for example, on the first one. And now it comes another tool, which is very great. We are going to be making smoke simulations. And the ones which are closer, I want them to have more resolution than the ones which are very far. So I developed a tool which is very easy to use. Basically, you just plug it in to any object. You select the camera, which is this one, and you select how big is the pixel when you see it from camera. So I want that one voxel, when you view it from camera, to be around 2.5 pixels. This will give me this value, which I will be then over here plugging into the Pyro solver. As you can see, it's exactly the same. And this value changes depending on how far is it. For example, in this case, the value is 0.01, but on the first one, the value is 0.003. So yeah, it's way more optimized. We are talking about orders of magnitude to optimize. Well, the trick here, if we open this node, is to create a box where we select the front, we select the back, we promote everything to points, and with the primitive we do a transformation. The transformation, I don't think it's too, I don't know why we are doing this, doesn't matter. But what we're doing here is to create basically a frustum. This is how you create it. You select the back and the front, and you select a padding. The padding makes is a float that is going to be used later on, but basically then this is going to be placed from camera. And the way this works is you create an from NDC geo and you select the camera. This is just the camera, right? Then this padding, well, I guess it works somewhere, the padding, I never use it. We delete the back, and the back, as you can see, is exactly the size of the screen, of the resolution. We delete the 0.0 and the 0.1. As you can see, there are some small dots over here, and we add them with a line. So this is placed, as you can see, in a distance. This distance is basically the distance from the center of the camera to whatever we are choosing to use, from the origin to, in this case, this box. So the closest point is going to be chosen by this distance from camera, and this is what we're going to be using. So the distance is from here to here, around 1 point whatever meters. Now, if we resample this with the resolution, we will have a line with tons of points. If we subtract the length of the first point with the second point, we will get a distance. This is the size of the pixel, and if we multiply it with the pixels, the size that we want, we create a value that is then going to be useful for us when we are in need to calculate the division size. And the division size basically comes from this multiplication of values. You just multiply the size of the pixel with the size of the voxel that you want to have, and this gives me this value in detail, which is 0.003, and this is the value at the end of the day which I'm going to be using over here to control the main simulation. Now we can select the frustum of the camera over here of the ground, and we can, for example, extrude it downwards, and this is going to be our collider. Then we are also going to be selecting a geometry, and this geometry comes from here, so we need to select it. It's coming from here, which also comes from the stage. So this is where I start to create some stuff. Let's go over here and let's remove the Arnold viewport just for a moment. So I decided to grab a gravestone. It's just an FBX with a material assigned and a scale. This comes from OD tools. You can look that up, but basically it's a way to drag and drop whatever we want, for example 3D. And when you drag and drop this, for example, you can select the renderer and to select Arnold, and boom, you have the assets in place. So very nice. So this is the assets. This is the ground, which I show you guys. And over here we have some other rocks. It's just a rock. The place move around a little bit with the displacements and the dicing that I want over here. I to 0.05, 0 value to 0.5. The same with this guy over here. And everything combined, this is our layout, as you can see, which I'm going to be using for the collisions. That's about it. So if we go back over here, over here, we unpack these two polygons and we boolean one with each other. We are combining the objects together, right? I'm also doing the same with the guys at the bottom, unpacking, extruding downwards, BDB from polygons, converting, and boolean them together. I didn't care much about the quality of these ones at the back because we're not going to be seeing them so much, so it doesn't matter. I generated some normals, added some color, and we're going to be booleaning it with well, this is very interesting. Basically what I'm doing is to select in which simulation I am, as you can remember if we choose another one. So we don't need the whole setup for this to work. We could just select one by one, and we can control where the collision is. Everything else is unnecessary for me to calculate it as a BDB. This allows me to use a high resolution, whereas if I were going to be using the whole setup, look at this, it's still calculating. This is massive. It doesn't make any sense. So it's easier for me to use booleans in this way. On this side, what I'm doing is to create, as you can see, I'm going to continue visualizing this. I'm creating a bounding box, which is clipped. This is where we're going to be generating the volumes. We are booleaning this with the ground, I believe. Yeah, exactly. It is boolean with the ground, so we don't waste resources. And we're going to use the Pyro shape. The Pyro shape, in this case, is a tool that I made, which creates volumes. It has a lot of useful tools, so you can control how it's animated, what do we have, temperature, density, velocity. We can visualize the velocities over here, so we can see exactly what's going on. We can use a collision if we want to, but we don't have. And the way this works is just an ISO offset. Literally, this is just an ISO offset set to density. We set this on, for example, to 100 sampling, with a fog noise, and this set to another ramp. We could always set to multiply. So that's it. There's nothing else. It's just how the tool works. Like literally it. But I decided to put some things for optimizations and whatever, as you can see, values. So the tool is a little bit bigger, but in essence, it's exactly the same. And for this, I decided to have a volume box at the top, which has a noise. If we preview the noise, it's a noise that is pointing downwards. So I don't want the volumes to be pushing forwards. I want everything to be near the ground. And that's the solution I decided to have. Which is just a velocity, right? So I'm outputting a velocity. Over here, basically this is with OpenCL. Let's just use another one because this is a little bit taxed. Oh no, this is okay. This is okay. No, let's just use this one, which is a little bit more interesting. No, sorry, this one. And for the sake of this video, I'm going to just duplicate this. The resolution is a little easier for me. And let's visualize how this looks. So let's see. It's going to be calculating everything into the GPU because this is minimal. So we have this over here, and we press play. The volumes are starting to get filled. This is the sourcing. I have velocity over here set to pull, which I'm not longer using because oh yeah, I'm using it. Yes, I am using it. Yes, I decided to rename the velocity here and to control this over here with a pull. So everything that's going a little bit upwards, as you can see, it will start to get pulled downwards. This is from the camera. An example, let's say we use another 0 and just load it again, I guess. Yeah, it barely survives. You see how it's pulling upwards right now because I have this inverted. But if I were to select to do everything again, go Control Z over here, we will see that everything is somehow being pushed downwards. So it's always going to be looking natural. It's a very subtle effect, but it works for me. So But that's the whole simulation. The only thing that I did is on fields, the cooling rate of the temperature to 0.8 because I'm adding temperature, as you can see here. I decided to lower the acceleration. Dissipation, it's 0.1, it's okay, everything is from scratch. I disabled the flames. The gravity, well, the gravity is what controls the buoyancy. So instead of coming upwards, I said, let's go downwards. The gravity, I set it to 1 because I didn't want to make it so fast. And this is like I'm using the temperature to drag everything to the left side. There is also a little bit of a wind, which is going also downwards to push it a little more. And a small disturbance with a small turbulence. Always the, I don't know, it's just not the idea of the tutorial, but it's always nice to have a little bit of disturbance and turbulence. On advanced, I always say this to PFECC and clamp, which looks just on output. I should have disabled these guys. I don't know why I'm outputting flame or CD, but yeah, that's it. Over here, I'm converting everything to 16-bit float. I just turn everything so it's more optimized. And then with this, it's very nice to have this one because it's what's going to be allowing us to blend between all the guys, right? Because I'm simulating on a bigger area, so we can overlap one on top of each other. Basically, based on the bounding box, which is always stable because this comes from a legacy solver, which is basically everything. I'm deciding to get the relative bounding box of the first input with the position, separating the Y and the X. And I can control as I please how this is going to be clipping on the Y axis, as you can see, or on the other axis, on the side, you can see. And this is what I'm basically saving over here. This is the same simulation with more resolution. And if I load all of them, no, not all the frames, oh my god, all the wedges, you can see that they overlap quite nicely on one on top of each other. Quite nicely, as you can see. So this is the whole simulation, there's nothing else. I mean, the most complex part is over here. So to continue with the Solaris part, I just saved everything here on an USD, so I don't need to load everything again. Over here, this is like the best way to load the volumes. What you got to do is to say, hey, how many iterations do you have? Oh, because I forgot, guys. Oh my god, I forgot to show you. Let's go back. Here is wedged. This comes from the same wedger. You need to save in background, and this will inside here save everything into subfolders with all the wedges. These are all different simulations, and all the simulations change of resolution. As you can see, this is awful and this one is very nice in resolution. So let's go back again. So what you got to do is to, hey, I have 6 simulations. So what you got to do is to, hey, let's load this. Let's send this over here first to the scene, background, and volume. Well, nothing is loaded, but I can set this to be loading over here. And let's save all the volumes over here. And how I'm going to reread this? Well, this is the field, and each iteration is going to be the iteration 1, and over here the same one. If I were to use another version, it would just change this number. So it loads all of them at the same time, and I'm going to be caching this to disk. This is the fastest way. It's not going to be saving the simulation again, it's going to be saving the direction of the BDBs, because we need to save this as BDB here. So it's going to be way faster for me to read this, whereas if I were to go do this, it's just going to be slower for me to go one step further. This is how you should do it. Then we merge both of these things. I added a dome light over here. There are no materials yet. I added the materials to the ground and to the volumes. The ground is just an albedo with a tree planner, cell and blend with some color correction. Let me just link them together. And I did a small camera edit so I can push forwards a little bit, and an Arnold render settings. Let me just disable the volume for now. This is on the foreground, and as you can see, everything is organized into layers, so it's easier for me in case this project has to be rendered separately. So if we were to render here with Arnold, it's going to be displaced in the ground and everything. So this is how everything is looking without the smoke. If we were to add the smoke on top, it's going to be looking something like this, which is a little bit more slow, but it's nice. Roughly 20 to 30 minutes per frame, depending on your setup. If you have a Ryzen 5900 onwards, but it's nice. These are the settings I just used. I selected the obviously which I wanted to use, which were just direct and indirect, and a small enable progressive and adaptive. These shouldn't go together, but I don't know. I used them. Max AA206 and 3 points of noise. Nothing else. Literally nothing else. In this case, I send it to the farm with. So I'm using Deadline. So all my computers are going to be working at the same time, and elsewhere I could just select this one over here and render this out. Remember to select the correct camera. That's the only thing. As far as the comp goes, this is super easy. This is just constant set to the resolution, which is 720p. I merge these guys together. I'm just shuffling the RGB to the RGB and selecting an luminance to select the nicest parts to create this effect, which it's just a glow with different sizes, as you can see. Merging everything by plus, multiplying to whatever I want, and merging on top of it to do a small pop. Then I'm transforming this a little bit bigger because I will then be using a camera shake. The camera shake moves everything around because I didn't want to make it in Houdini. It didn't make sense for me. Then I have small color correct. It's just a small contrast and a little bit more red. A lens distortion with on negative 0.04. Then I'm making a small adjustment, as you can see, because the camera shake might clip my image out. Then I'm just transforming after the lens distort, always after it, not before, never ever. Just the red channel on 1.002, so create a little bit of a chromatic aberration, then cropping everything so we don't have this excess of the bounding box. Doing a grade with a mask over here. This is just a multiply and a color correction on top of it to make it a little bit more dark with a small noise on top of it, and just output this as a mob on output sRGB. That's it, guys. I hope that you like it. I hope that you like the video. Please leave a comment, subscribe, and stay tuned for the next video.